Now it's time to start designing. Where do you begin? Well, Fusion 360 integrates freeform, parametric, sheet metal, direct, surface, and mesh modeling all in one package. Go ahead, use whichever modeling technique you are most comfortable with to get the job done. Now, let's take a look at these different techniques. First, when was the last time you looked at a concept sketch and wondered how you were going to model that shape? Did you sit down and plan your sketches, set up your work planes, and fight with transitions between lofts? Once you use the freeform modeling tools inside of Fusion 360, you'll never look at concept sketches as a mere suggestion again. In this example, the user was able to create a form in seconds, grab some vertices, and start to work the form with simple push-pull gestures. Yeah, try doing that with a loft. Once you get the shape you're looking for, this shape is treated just like any other body or component in Fusion 360. Now, when it comes to engineering a product, having parametrics is essential to ensure the location and size of your features are correct. Many of us who have used other CAD tools understand the benefits of solving the design mathematically, knowing that changes need to propagate throughout the rest of the design via parameter relationships, so of course we put this into Fusion 360. Start by setting up your sketches, drive them with constraints, parameters, or equations, and then turn that 2D sketch into 3D geometry. In this mode, features are captured in time, making it a piece of cake to make changes to geometry when that inevitable design change occurs. Now, we don't just have solid modeling. Of course, we threw in surface modeling tools for those complex shapes, or simply use surfaces as tools to cut, split, and change geometry. While solid modeling is great for designs that are 3D printed or cut on a CNC machine, what about those parts formed from sheet metal? So we brought tools to bend and lay out sheet metal designs. But we didn't stop there. We combined the numerous sheet metal commands seen in traditional CAD tools into a single flange command. But once your sheet metal design is created, flatten it and take it to a drawing or to the CAM workspace to cut on your plasma cutter. Next, if you don't want to drive these designs parametrically, we can switch over to a direct modeling mode. Now we can translate, rotate, and change geometry without fearing of breaking a complex feature tree. This is perfect for editing, defeaturing, or repairing imported geometry from other CAD tools, or before running an FEA simulation or CAM toolpath. Finally, let's edit and repair mesh files right inside our CAD tool. Take STLs or OBJs from your scanner or other CAD tool and edit them right inside the same package as your engineering tools. Use this mesh to make a sketch cross-section, and now we can add parametric features right to that design. Fusion 360 gives you the flexibility to choose your preferred modeling method when it's most convenient in your product development process. Even combine them to get some really slick workflows. Now that our parts design, let's switch over to some assembly modeling. Assembly modeling with Fusion 360 allows users to model with the techniques they are most comfortable with, and ushers in new assembly modeling techniques that will reduce the amount of time it takes to complete your designs. Let's take a look at a couple examples. Fusion 360 provides a new component creation functionality while in the context of geometry creation. This method doesn't force the end user to first be in the right environment or create and name a file, then return to the modeling environment. Next, let's model another component. Again, referencing geometry between components is fluid and efficient. But what happens when you decide that this component really needs to be two parts that make up a subassembly? It's simply not an issue with Fusion 360. Make components at the point in the design that's most appropriate, and the structure takes care of itself. Sketches, bodies, components, and subassemblies can all live within the same design. And don't worry about placing features on components at the wrong level of an assembly, even though this component was not set as active. Fusion 360 associated the feature to the component automatically. But not every part is going to be created in context. Many of your components are going to be reused between multiple assemblies. Grab a part or subassembly from your projects, move them into position, and generate the relationship between moving components with a joint, much the same way you might reference other parts or assemblies in other CAD tools. With Fusion 360, we're taking assembly modeling to the next level by capturing the working relationship between components with joints. Joints describe the mechanism in the form of rigid, revolute, slider, cylindrical, pin slot, planar, and ball. Each part in an assembly has a working relationship with it. Components have range of motion, hard limits, relationships, and cause and effect. Yet joints serve the purpose of positioning components relative to one another, but with the intelligence you've asked for. Finally, many of us aren't designing just enclosures or just PCBs. We're designing products. So we brought an integration from Eagle to Fusion 360 that is truly bidirectional. Changes to the layout of the electronic design will propagate to both the electronic and mechanical designer, which ensures all team members are working with the latest iteration of the design. To put it simply, spend less time thinking about modeling and more time innovating with Fusion 360.